All right, I think we are good. A very warm welcome, everyone. Those who are tuning in, we have got Gunnar Grosch with us. He's joining in for the third time in a row at Chaos Carnival, and I mean, it's been a pleasure to have been hosting him since the initial days. And today he's going to talk about security chaos engineering. I think it's one of the hot topics out there in the chaos engineering space. And Gunnar, as a senior developer advocate and AWS, is going to share how you can verify your security posture using security chaos engineering. So I think without any further ado, I would allow Gunnar to take center stage and introduce himself, share his thoughts on security chaos engineering. Thanks, Gunnar. The stage is all yours.
All right, thank you very much, Prithvi, and super happy to be back for the third time out of three possible times as well. So very excited about that. So as systems continue to modernize and evolve, so does the risk landscape that impacts them. Many security issues are challenging to discover and patch quickly, affecting application or system functionality. And additionally, security incidents can be tricky to uncover during the development phase. Like Prithvi said, my name is Gunnar Grosch. I'm a developer advocate at AWS. And in this session, I want to explore how you can use experimentation and failure to identify potential vulnerabilities. And you will learn how to use security chaos engineering to verify your system's security posture and develop a more proactive approach to security. So, who doesn't love a very short agenda? I do, for sure. We're going to start off by having a quick look at the modern security landscape just to set the scene around security. And then we're going to move on to talk about chaos engineering into security chaos engineering. And then for perhaps the majority of the session, we're going to see security chaos engineering in practice using a couple of examples. So without further ado, let's get to it. So we're going to start off with the modern security landscape and just have a brief look at what it actually means with security today in the way that we build and ship applications today. And I think traditionally, many organizations have been forced into a very binary trade-off. Either you move quickly or you stay secure. And due to the overly manual security processes, InfoSec has often been forced to slow things down to human speed so they can ensure that the security of the organization is as secure as needed. But now, of course, with the cloud, it's possible to automate many of the basic security tasks, such as patching, for instance. And with the right tooling, you can gain the visibility needed to accurately identify and monitor critical assets and data. And with the cloud, all of this, of course, is made easier. So you can stay agile while maintaining and, in many cases, improving security. And by providing highly integrated logging and monitoring, as well as different integrated tools to automate these core security functions, organizations can make use of the cloud to innovate quickly and maintain that high security posture that we, of course, strive for. And the cloud is designed to help you build secure, high-performing, resilient, and efficient infrastructure for your applications. And you want to make sure to have this strategic approach to security, of course, when you do that, so that the services and solutions that you're using and building, that they are focused on delivering that benefit that is critical to helping you implement your optimal security posture. And there are a few key strategic benefits with the cloud and with the way we work with security I want to point to. First off, prevent. Well, with thinking about it from a prevention standpoint, you can define user permissions and identities, infrastructure protection and data protection measures that helps you have a more smooth and planned cloud adoption strategy. The second one is detect, where you gain visibility into your organization's security posture with logging and with monitoring services. And you can then ingest this information into a scalable platform for event management, for testing, for auditing, and so on. The next one is in Respond, where you can have automated incident response and recovery to help shift the primary focus of security teams from response to then instead analyzing the cause of different security incidents. And finally, remediate, where you can leverage event-driven automation to quickly remediate and secure your environment in the cloud in near real time. So with these four key strategic security ways of thinking, with prevention, detection, response, and remediation, you have a good baseline for your security in the cloud. At AWS reInvent in 2022, there was this great session doing a deep dive on the current security threat landscape that we see within AWS. And it's basically showing data from our different security services on the type of threats that we see customers facing today. First off, we see a lot of policy-related threats. This can be such as IAM user or root credential usage. It could be S3 bucket that have their public access block disabled, or it could be S3 bucket anonymous access that is granted. We also see quite often unauthorized access using, for instance, inbound or outbound brute forcing to gain access into your environment. Another common one is stealth threats, where, for instance, a bucket or a service access logging is disabled by the threat actor. So you won't be able to notice and then see in the logs that something is happening within your environment. Attacks against infrastructure and applications is, of course, a common security threat today as well. And these are such as DDoS or web exploits and different types of botnets. And then, of course, this different kind of ransom threats that we see. And these are, for instance, ransomware, but also the most common one, that is data destruction, where the threat is basically that they want to destroy your data. And these five combined, well, they are no small threat. And if you're following that strategic approach to security, we should have a good start and to create that good security posture. But just like when we're talking about system resilience, we don't want to wait to know if we are resilient to failure or resilient to a security threat. We don't want to have to wake up in the middle of the night to an alert, for instance. And just like we want to know if our, say, highly available database cluster works with failover the way we intended it to, we want to know that we have a strong security posture when that web exploit strikes or when someone tries to gain that unauthorized access into our environment. And for system resilience, well, the practice of chaos engineering, of course, helps us do that. It helps us build that confidence in our system. And I know we're more than halfway through the first day of Chaos Carnival, so most of you probably know what chaos engineering is by now, but just bear with me. So chaos engineering is the process of stressing an application in production or pre-production environments by creating these disruptive events. And we do this and then observe how the system responds to these events, and finally then implementing our improvements. And this is something we do to either prove or disprove our assumptions about the system's capability to handle these disruptive events. But instead of letting them happen in the middle of the night or during the weekend, we can do it in a controlled environment and during working hours. And one important goal with this, of course, is to increase our confidence in the system and the system's resilience to failure. So we know what chaos engineering is, and we know the benefits of chaos engineering. So how do we then make use of that knowledge and those benefits in security field instead? And then move on from chaos engineering to security chaos engineering? Well, the practice is still the same. We still lean on the principles of chaos engineering and that very scientific method of experimentation. If we go back to that earlier definition in a, I know, overly simplified way, we can tack on security in front of it. Because it is still stressing an application by creating disruptive events. It's just that this time, these are security-related events. And many of you might recognize the chaos engineering flywheel that shows us the phases for this well-defined scientific method that we know takes us from understanding the steady state of the system we're dealing with, but now in terms of security posture instead, and with the help of our security tooling. So we define the steady state with the help of the security tools and observability that we use from a security perspective. And then we, of course, articulate an hypothesis. But now, instead of the resilience of the infrastructure and so on, this is an hypothesis around security. What if we have a DDoS attack? What if there is unauthorized access to an S3 bucket? And then we form an hypothesis around that. And then we, of course, design and run a security chaos engineering experiment where we test that hypothesis. And with the help of that experiment, we can then verify the result, verify if that hypothesis is the way we believed it was. And then finally, of course, just like with chaos engineering, we learn from the experiment in order to improve the system. And when it comes to security chaos engineering, well, these could be improvements such as perhaps our automated remediation, alerts to different security threats or incidents. It could be into the security posture of the overall system. And there are many different examples of security chaos engineering experiments we can do. Just like with chaos engineering, it's a matter of what your system looks like and what type of services and so on you are using. But this is just an example, some security chaos engineering experiments we could do. We could, for instance, make an Amazon S3 bucket public. How do we then notice that from our security perspective? We could open an unapproved port in a security group. We could create an experiment that runs crypto mining on an instance, or simulate crypto mining, perhaps. And we could make unapproved policy changes within our system. And we could perform port scanning on instances. We could run a brute force attack, and many, many, many more, of course. So we create our security chaos engineering experiments just in the same way that we create our chaos engineering experiments. And do these experiments then to verify. And we verify, for instance, are you permitted to do this change or do this addition? Is this experiment at all detected by our security services? Does anyone respond if we make this change that is unapproved, for instance? And does this get automatically remediated, which is in many cases what we want to do in terms of proactive security? So with that as a background, I want to jump into showing examples of security chaos engineering in practice. And I'm going to be using AWS Fault Injection Simulator, or FIS, to do this. But you can, of course, do it with any tool you have available. But since I'm going to do that, I'm going to show just a quick overview of what AWS Fault Injection Simulator is. It is, as some of you might know, our fully managed chaos engineering service. It's designed to be easy to get started with if you're using AWS today, and it allows you to then test your system against these real-world failures. And AWS Fault Injection Simulator fully embraces the idea of safeguards, which is a way to monitor the blast radius of your experiment. So you can stop the experiment if certain alarms are set off. And there are 4 main components that are good for you to know before we jump into the demo. The first one is an action, and that is the fault injection activity that we run on our targets using AWS FIS. And these could be actions from a chaos engineering standpoint, such as terminating an instance, or it could be adding latency and so on. Then we have a target, and that is a specific resource within your AWS environment, or perhaps one or more resources that match a specific criteria that you specify. For instance, resources with a specific tag. An experiment template contains one or more actions that we run on one or more targets during an experiment. And it also contains the stop conditions if we add those, so you can prevent the experiment from going out of bounds. And after you create this experiment template, you can reuse it to run experiments over and over again. And then, of course, we have the actual experiment. And this is after you create your template, you can use it to start your experiment. All right, so that was a brief overview of AWS FIS. So now let's look at the first example. And I mentioned brute force attacks previously as one of the common vulnerabilities or common threats that we see. So the first one I'm going to do is showing an RDP brute force attack. And we, of course, need to follow our scientific method and first create our hypothesis. In this demo case, we're just going to imagine that we know the steady state of our system without going into depth there. So our hypothesis in this case is that if an instance has been used to perform an RDP brute force attack, it will be observed by guard duty and remediation can then be performed. And that could, for instance, be isolating the impacted EC2 instance, or it could perhaps even be terminating it, depending on what type of instance this is. And to do this experiment, we first of course need to create or select our action. And in this case, we're making use of SSM run command, and we're using an SSM document that then contains commands to do RDP brute force. And we're targeting one specific instance. And the way that will actually work is that we have two different instances where one instance will target the other instance. So with that, let's jump into the demo and see this in action. So the first thing we see here is the AWS FIS console. Jumping over quickly to the EC2 console, you can see that we have 3 EC2 instances running. In this case, we're going to make use of red 1 and blue 2. So I'm creating a new experiment template now. First, got to give it a description and a name. So let's call it RDP brute force as a description, and then RDP brute force as name, keeping it simple. And the first thing we need to do, of course, is add our action. We're just going to use one action. I'm giving that a name, but we could add multiple actions in the same template. As I mentioned, I'm going to use SSM run command or send command. So I'm selecting that. And next, I will then point to that document that contains this RDP brute force commands. So that is an SSM document and the ARN to the document. And then I need to add certain parameters to be able to run this. So simply pasting a JSON string with those parameters. And this contains just the IP address of the target for our brute force attack. I'm setting a duration of 5 minutes for this action, and then we can save it. And the next thing we need to do then is define our target that will be running this SSM document. And we're going to select one specific resource ID in this case, but we could also use tags and filters and so on. So I'm now selecting the red 1 instance and saving that. Then I need to add my IM role, that is the role that's running the experiment. That allows me to run this experiment. I'm skipping stop conditions in this case, but this is where we would be able to add those. I'm creating my experiment template, confirming that I want to create it without a stop condition. And now with that experiment template created, we can move on to run our security chaos engineering experiment. Clicking start and confirming that I want to start it, because this will actually perform the actions that I've added. And now we can see that this experiment is initiating, and if we refresh, we can see that it's moving into the running state, and the experiment is now running, and shortly after it will then start running that action that we added as well. There we go. So what's happening right now is that Systems Manager is using this command and running it on our instance. And that command, if you remember, will then do a brute force attack towards the other instance. The experiment completed, skipped through a couple of minutes of the experiment. And what we wanted to test in this case was if we were able to then notice this. So I'm jumping over to Guard Duty, which is the security service that we're using in this case. And as you can see, one of the findings for Guard Duty in this case is that we've found an RDP brute force finding in this case. So one of my instances is performing RDP brute force attacks against the other instance. Shortly after, it would also likely show up as a finding from the other instance that that instance is under attack as well. And if we switch over to Security Hub, we can see that those findings are there as well. And with the help of these findings, we can then do the type of remediation that's necessary. If that is just alerting someone, or if it is actually doing an automated remediation, and in this case, for instance, isolating an instance. And this gives us all of the details around what was happening. And we also have it in JSON format, as you can see here. So this was our first experiment, where we then used RDP brute force between two instances in our environment. And this is to then verify that our security systems, Guard Duty and Security Hub in this case, will be made aware of, have that as a finding that this type of attack is happening. So our hypothesis in this case was proven, and we then could see these findings. All right, so moving on, I want to show the second example. And in this case, we're going to use one of the other common security threats that we saw earlier, which is public access in security group, meaning that we give access into our environment through a security group. And in this case, we're doing the same thing. We're creating our hypothesis to begin with. And the hypothesis in this case is that if an unapproved port is opened in a security group, the change will be picked up and then rolled back. So we have automation in place to see this change and then roll that change back. The experiment design in this case is that we will be using SSM start automation execution and then run a specific document that we have to create this security group fault. These documents allows us to create very customized experiments. And we're targeting one specific security group. So let's start this. We are back in AWS Fault Injection Simulator, and we can see that we have two security groups. This security group contains two inbound rules. They both are for port 3389 and for specific IP addresses or sources. We also have a rule in AWS config that is basically checking for public access in our security groups. So if that is found, it would then create an event that is sent to EventBridge in this case. An EventBridge, in turn, will then see that this is a non-compliant event and that it is, in this case, incoming SSH, and we will then take action to that by running an AWS Lambda function that simply remediates, and in this case, removes that access within our security group. All right, so let's create the experiment template. Once again, starting off with creating our template, adding a description, and then adding a name to the experiment template. Open SSH. I then need to add my action, give the action a name, and selecting the start automation execution like I mentioned. And once again, I need to define which document I'm going to use. And in this case, we're doing everything in the AWS FIS console, but this could, of course, be used with templates within your IDE, for instance, as well. So for this document, we need to add some parameters. We need to define which security group we want to target. So I'm simply taking the name of my security group and adding that in the parameter, and then set a duration for my action, 5 minutes once again. Saving it. In this case, we don't need to define a target within FIS in the template. Still need to select the IAM role, of course, that allows me to run this experiment. And then I create the experiment template. With the template created, we can move on and start this security chaos engineering experiment as well. I confirm that I want to start it. This will run in my environment. The experiment is started. And once again, it will go through the initiating phase, then to actually running that, and then running our action as well. So if we now switch back to our security group and refresh it, we will see that AWS FIS, through that action, will then add an additional inbound rule, in this case port 22 for SSH, and public from anywhere. So if we switch over to AWS config, we can see that AWS config has now found that this rule matches, or this security group matches our rule. And as we saw before, that means that it will send an event through EventBridge. EventBridge will kick off our AWS Lambda function, and the Lambda function is then supposed to remove this inbound rule. And if we check, we can see that yes, that happens. So the automation that we have in place actually works. It is able to then remove that inbound rule. And shortly thereafter, AWS config shows that there is no security group matching that rule. And the AWS FIS security chaos engineering experiment is now completed. And we once again verified the behavior. We could see that our hypothesis was correct. And if one of those unapproved rules is created, it will then do the remediation automatically and remove that rule. All right, so we're approaching the end. So just some key takeaways from this session. Experimentation, it helps you identify potential vulnerabilities within your environment. And using security chaos engineering, it helps you verify your security posture. So you might have a high security posture, but now you can verify it by doing these experiments. And we're following that scientific method of chaos engineering when we're doing security chaos engineering as well. And many of the experiments we do, they might be small, but I can promise you that they give you a large result. If you want to learn more, I've gathered some resources in the link shown on the screen right now. So you can scan the QR code or just enter grosch.link/SCE. And with that, I want to thank you all for joining in this session where we looked at how you can use experimentation and failure to identify potential vulnerabilities. And also, of course, how you can then make use of security chaos engineering to verify your system security posture and develop a proactive approach to security. Thank you very much.
Well, Gunnar, thank you so much for that amazing session. And we've got some questions here on security chaos engineering. I think it's a topic which a lot of folks are contemplating on. And that's why I see a lot of questions. So I'll quickly go through them because we'll be moving into a 15-minute break come quiz session after this. So the first question is by Nilanjan. Uh, Nilanjan is asking how are SLO thresholds determined and translated as the chaos hypothesis for the security chaos experiments?
Let's see, how are the SLO thresholds? Well, I suppose you can make use of those thresholds when you are creating your hypothesis. And when you create an hypothesis, I often tend to start off with an what if questions to ask and to then create my hypothesis around it. And then it's a matter of having an if something happens, then this should happen. And if you want to make use of your SLO thresholds in that hypothesis, I suppose you can do that. I'm trying to come up with a good example of how that could be. Might have to come back on it.
Nilanjan, I hope you'd love to follow up with Gunnar.
I'll be in the
Post-
Slack channel, of course. I'm happy to continue there.
Sure, I think there's another question by Nilanjan. How can we replicate DDoS based security experiments while ensuring the scale of geographically distributed requests?
Yeah, DDoS experiments is of course a bit challenging to do. First off, you can't really perform DDoS towards your cloud environment without the cloud provider likely. Well, first off, they have to be notified, and secondly, it might be that you're still not allowed to perform it. So DDoS is one of those kind of hard things to test using security chaos engineering, I would say. But you could still likely do it on a smaller scale. You should have, I would say that in most cases, you should be able to pick up even smaller DDoS attacks using the security services that you have in place. Just make sure to have permission from your cloud provider before even attempting to do it.
Right, I hope Nilanjan that answers your question on DDoS experiments. Next up, we have John who asks, how is security chaos engineering seen today in comparison to, say, a couple of years ago?
Well, it is, I would say that it is likely where chaos engineering was maybe 3, 4, 5 years ago. So we are now moving towards a phase where more and more companies are adopting this approach. And there are multiple examples of companies that are using it. And know, for instance, that Aaron Reinhardt, who was, I would say, the creator of the security chaos engineering practice, the work he has done and the work of many others in the field has helped make this a practice that more and more are using as a way to then understand and know and verify their security posture. So it is a young discipline still, but it is definitely picking up, and one of the disciplines that are very interesting to talk about with customers today.
Absolutely, Gunnar. I agree with you on this point here. And I think the practices which initially were shared by Aaron, I think they have been coming in. A lot of folks have been extending those practices. And
Mm.
I think the future of security engine, chaos engineering itself is looking bright and a lot of inputs coming there. So, one last question by Adarsh. How can we integrate security chaos engineering with monitoring tools?
So um, I suppose it depends on what you want to monitor in that case. If it is the outcome of the experiment, it probably depends quite a lot on what you are actually experimenting on. When we talk about regular chaos engineering, as I think we can call it these days, observability is of course key. Understanding your steady state and then being able to use that steady state to verify the behavior after your experiments. That's something that we want to replicate with security chaos engineering as well. But often, in many cases, it's about monitoring other things. So maybe we aren't monitoring the traditional infrastructure metrics. It's more about monitoring the number of events, for instance, within the security services, like with Guard Duty or Security Hub, for instance, that we have monitoring on those types of events instead. And then you can make use of those to use alerts. You can then make use of it for aborting experiments, for instance, if thresholds are met.
Absolutely, Gunnar. Thank you so much for answering all the questions for us. I hope this gives a lot of insight to folks who tuned in for the session. It always does for me, for sure. Nadesh, I hope this answered your question. With this, I believe we have come to the end of this session alongside the Q&A. If there are any more questions, feel free to ask them on Slack. And thank you once again, Gunnar, for joining us for a third time in a row. And it's been a pleasure always to host you. And up next, we are having a quick quiz gaming session. Feel free to join that, and post that we'll have the last session for the day. So, Gunnar, thank you once again. And I'll hopefully we'll see you again next year. And feel
Yeah,
free to watch the other sessions as well. Thank you. Thanks a lot, Gunnar. And thank you so much, everyone, for joining in.
thank you very much, Prithvi, and thanks everyone for watching.
All right. Thanks, everyone. Bye.